2 is a semi-annually compounded problem. So I need you to start with A equal P1 plus R over N to the NT. So now N is going to be 2 because it's semi-annually compounding. Now if we started out with 50 and ended up with 80, 1 plus the rate is what we're looking for divided by N, which is 2, and the time it took is 8 years. Now what we're going to do is solve for R. I'm going to divide by 50, and then I have 8/5 is equal to 1 plus R over 2 raised to the 16. Now when you raise something to the 16, I need you to 16 root both sides. To do the 16 root on both sides, this is going to give us 1.0298, and this is going to give us 1 plus R over 2. Subtracting 1, R over 2 is equal to 0.0298. Multiplying by 2, and R is going to equal to 0.0596, or simply, R is a rate, you can make it as a percent. R is equal to 5.96%. If you give me 6%, I'm okay with that. Okay, number 23, I'm going to start with this formula. Of course, you can use the PERT, but I chose to use this one because I wanted to show you, it'll get you very, very close answer. Now, we want to know that the population has doubled. So we started with 1. This has ended up with doubling, 1 plus R, and it took 12 years. So now to solve this equation for R, the rate at which it's increasing, I'm going to do the 12th root of both sides. And to do the 12th root on your calculator, this is going to give us 1.05946 is equal to 1 plus R. Subtracting 1, R is 0.05946, or simply put 5.9%. Now continuing with the problem to answer the question, we want population to triple. So if we start with the same formula, I want 3 equal to the amount that you started out with. And this will be 1 plus the rate, which is 0.0595, and we're looking for the time. Now I want you to log both sides. That will give us log of 3 is equal T times the log of the base, which is 1.0595. Solving for T, that will be log of 3 divided by log of 1.0595. And this is going to give me an estimation of 19.008, or simply 19 years will be good. What does that mean? That means the first 12 years, population double. Now what I want you to know, how many more years for the population to triple? It's only 7 years, 7 more years for the population to triple. I want you to know we're doing a half-life again, and so we're going to start with A equal PE to the RT. So we started with 1, we want to end up with a half, and it took 64 hours, so 64 times R. We want to solve for R, ln both sides, and so that will give us 64R, and looking for the rate, it's ln 0.5 divided by 64. You should know the rate here is going to be negative because it's decaying to half, 0.0108. Next, we're going to try to answer the question. The question was, what will it be if you start with 50 grams and you want to use the same rate, 0.108, and the time we're going to wait is 22 hours. And so if you multiply all of these together, I got 39.3995. If you simply gave me 39.4 gram is good enough. Anywhere here is good. 25. We're going to start with PERT again, but I want you to know this time you're starting out with 7 gram, and the 7 gram is going to decay to 4.02 in 64 hours. So that will be E raised to the 64 times R. We need to solve for R. I'm going to divide by 7. And when you divide by 7, you get 0.5743 is equal e raised to the 64r. ln both sides. ln 0.5743 is equal to 64r. And if you're solving for r, you're going to find that r equal ln 0.5743 divided by 64. It's going to be negative 0.0347. Okay, now we're going to go ahead and answer the question. The question is, what is the half-life of the isotope? So what I want you to do now is start with the formula, A equal PE to the RT. You're going to start with 1. You want to end up with half. It's the half-life. You already got the rate, and the rate we just found it to be 0.0347. Make sure you put a negative because the rate is negative. It's a decay. We're decaying to half, and we're solving for time. Now, if you ln both sides, and so that's going to give you negative 0.0347t. And so the time will be ln 0.5 divided by negative 0.0347, and I got approximately 19.996. Can we simply put 20 days? Okay, this one here is going to be a compounded quarterly problem, so n equal to 4. I have no choice but to use the compound quarterly formula, which is going to be this formula, and then we're going to fill in the blanks. So now the money was left for Howard is $1,000, and then it grew to $2,800, and 1 plus the rate is what we're looking for, compounded quarterly, and we waited from he was 8 years old till he was 21 years old, so we waited 13 years. And so to solve for r, I want you to divide by 1,000 on both sides, and this is going to give us 2.8 is equal to 1 plus r divided by 4 raised to the 52. Now we're going to solve for r. We are going to take the 52 root of both sides. And so this one here gave me 1.01997, and this gave me 1 plus r over 4. Subtracting 1, r over 4 is equal to 0.01997. I think there is one more 9 and then a 7. And then if you multiply by 4, I got the rate to be 0.07999, or simply put, could I make it an 8%? Number 27, we have y equal a. It's just an investment problem. I could use PERT if I wanted to. I'm choosing to use this one. So I started out with $1,000, and it grew to $1,500. And this is going to be 1 plus, we need to look for the rate for 7 years. And so if you divide by 1,000, and so that will give us 1.5 is equal to 1 plus r raised to the 7th. I want you to do the 7th root of both sides. And if you do the 7th root of both sides, subtracting 1 from both sides, you will get r is equal to 0.0596. Next, what we're going to do, we're going to answer the question. The question was, how long will it take for the investment to double? Well, to double the investment, here's what we want to do. To double, we want to start with 2. Start with 1, and we want it to double. That's going to be a 2. 1 plus r, the r we found it to be 0.0596, and we're looking for the time. And so 2 equal 1.0596 to the time. Log both sides. Log of 2 is equal t log of 1.0596. And then solving for t, t is equal to log 1.0596 divided by log of 2, which gave me approximately 11.97 years, or you can make it 12 years, no big deal. 28. I'm going to start with PERT. A equal PE to the RT. Now to decay to half, we started with 1, ended up with a half of that, and we're looking for the rate. it took 1600 years to go to half. ln both sides, ln 0.5 is equal to 1600 r, and dividing by 1600, ln 0.5 divided by 1600, and so that's going to give us negative 0.00043. As you can see, I did 5 decimal places just before accuracy. I have too many zeros. And so now to answer the question, it says to you, what percent remain after 300 years? So now what I want you to do, use the PERT again, and because we're looking at a percent out of 100, how much remain? So because it's a percent, the rate we found it to be 0.00043, and the time is 300 years. Please keep 5 decimal places here. And then if you calculate it, you will have 87.81%. Ta-da!